Taran's classroom, friends. In today's class, we are going to learn about magnetism. So, what is magnetism? So, magnetism is the study of the properties and the characteristics of a magnet. So, now what's a magnet? A magnet is a substance which can attract small pieces of iron. So, there are different types of magnets. So, first of all, let's learn about the discovery of magnets. So, in 800 BC, a shepherd known as Magnus, who lived in Magnesia, so he went to a small hill for grazing his sheep. So, at that time, the iron, so this is one example of an iron, hook of his stake got stuck to a rock containing magnetite. He pulled, but he couldn't. And the hooks of his shoe also got stuck, but he couldn't pull it off. Later, this rock was found to be having magnetite or lodestone. So, it's an example of natural magnet. So, later discoveries were found that when this rock has been suspended with the help of a string, so this is a magnet, has suspended with the help of a string, it always rests in the geographic north-south direction. Hence, it can be also used for finding directions. Now, let's learn about the types of magnets. So, natural magnets. A ore of magnetite or lodestone is known as a natural magnet. So, they are found in nature, in rocks. Okay. So, they are very weak in strength and they are irregular in shape. So, this is an example of a lodestone. It's also known as iron fillings. Can you see it? Okay. It seems to be a cluster of mud, but actually it's not. I'll show you. Can you see? So it's not a lodestone or magnetite, but don't think it's a magnet. This is a magnet. No, it's not a magnet. Really, it's not a magnet. So if you keep near, see. So this is also an iron object. If this is a magnet, it may have attracted it. See, it's not getting attracted. Okay. So these is known as natural magnets. They are weak in strength and hence they cannot be used for practical purposes. So for practical purposes, artificial magnets are made. So here a small mistake, it is artificial. Okay. So artificial magnets are nothing than the magnets which are made by man. So there are many types of artificial magnets and they are used for many purposes. So these are some of my collection of magnets. So there are many different types of artificial magnets. I'll just explain them. So this is one type of line magnet, ball magnet. This has ring magnet. Can you see this? Ring magnet, dot magnet. This is the most common one. That is bar magnet. I have attached to a string because we'll be having an experiment. And there are also different other type of magnet known as electromagnets that will be seen at the last. So these are my collection of magnets, but there are many. Magnetic compass, then magnetic needle, U-shaped. I had, but it's lost. U-shaped magnet, horseshoe magnet. There are many types of magnets. Okay. So that's about artificial magnets. Now magnetic and non-magnetic substances. So now we learned about magnets. Now we are going to learn about the substances which get attracted to this magnet. So there are three main substances: iron, nickel, and cobalt. So these are magnetic substances. So they are nothing than substances which get attracted to a magnet. What's an example? So this is an example of a magnet. So now I am keeping it near this. It's getting attracted. So is this a magnetic object? Substance? Yes. Now so this is an example of a plastic. This area, and so this is a thread. No, it's not getting attracted. So it's non-magnetic substance. So there are many like bauxite, then bismuth, paper, then wood, etc. So these are some of the examples of non-magnetic substances. Now the characteristics of a magnet. Okay. So now we can learn about the main characteristics of the magnet. So there are two main characteristics. One is it attracts small pieces of iron, and the other one is when it is suspended freely, it always rests in a specific geographic north and south direction. So these are the two main characteristics of a magnet. But in extra there is also one point. That's it has two poles, north and south poles. Okay, now we can learn the first point. So it attracts more pieces of iron. So you may think, oh, it's just a common property. It always attracts more pieces of iron. But I do not mean that. I'll show you why I do not mean. Okay, so this is a magnet, right? So how many poles it has? Can you see? North, south. It has been mold. Just trace it here. Can you see? Okay, so it is north and south pole. Two poles it has. So sometimes in some magnets, without writing this north, you see a dot here. A small red dot is etched on one of the poles of this magnet to show that it's the north pole. Now I'm just placing it. I think so. You can see. Is scattering this. Can you see? So here, is there any of these iron fillings stuck to the middle? No. To the poles? Yes. So now what do you conclude by this? So according to me, the conclusion is the magnet has the strongest magnetic attraction in the sides, that's in the poles, and it has the least attraction force in the middle. So the strongest attraction force sides are known as the poles. A magnet has two poles, north as well as south poles. A fact. Poles are not exactly located in the ends of magnet. They are actually located a bit inside. Okay. So now we can learn about the properties. So there are many properties of a magnet. So one of it is, sorry, I didn't show you one thing. That is, when a magnet is suspended freely, it always rests in a specific direction. So this is how a magnetic compass works. So this is a dot magnet, and I have been suspended with the help of a string. So we can also suspend the string in an iron stand because I am not using it. So it's been for a little time. And now see, you may think that I did something. No, I just make it not to shade. So now it is resting in this direction. So in order to check, I'm just taking my compass and then just placing. Of course, it's right. North is here. So this is the north. This is the south. It pointed here and south pointed you. So this is the one of the other characteristic. That is, it always rests in geography, north and south direction. This is the principle used for the magnetic compass, which is used to find directions. Now properties. So the first property is like poles repel, unlike poles attract. What do you mean by it? First of all, what's like pole and what's unlike pole? Like poles are nothing than. So here it's not written. This is north pole. This is south pole. So here also this is north pole. Look at here. I can feel some force. I couldn't even move it. Why? So this is because of a process known as repulsion. So see, it's not even getting attracted. So in the other way, see, it's also not getting attracted. So these are only known as like poles. North, north, known as like poles, and they repel. Now see, north, south. It gets attracted. So like poles repel and unlike poles attract. That's the first main property. Poles exist in pairs. So if I break a bar magnet in the middle, you may think, just a waste, I'll put it in dustbin. You may think. Of course, if you want this, you'll put it in dustbin, but it's use. So this is the one ring magnet. I just put it down. It just broke into 3 pieces. So now you may think that I cannot fix it, but I can. You may think, with gum. No. Look here. It is almost fixed. So this is how poles exist in pairs. So this becomes the north pole and this side becomes the south pole. So if I break this bar magnet into 2 pieces, here already north, here already south. So this will become south pole. If I break it in the half, this will become the south pole, this will become the north pole. And we conclude that these pairs always these poles always exist in pairs. Even if I break into pieces, millions of pieces, they always exist in pairs. So each broken piece has all the characteristics of a magnet. It attracts iron pieces. So look at here. It attracts. And when suspended to a string, it always twists in north-south direction. So this is another property of a magnet. Okay. So these are the two main properties. So the other properties are like that is, it has two poles, north and south poles, as well as when it is suspended freely, it always twists in the north-south direction. So now we learn about the main properties of a magnet. Now we learn about the magnetic field around the magnet. Okay, so what do I mean by magnetic field? So, okay, so this is a magnet, right? So this magnet has some space around it. So the around space is that area which an iron piece get attracted to this magnet. So this area, there will be some area around the magnet. So there known as the magnetic field. If you need to explain it clearly, just look at here. Here, I just did it. So when I keep this magnet just under this just take a stiff piece of paper, these iron pieces, they arrange themselves in a definite manner. You can see that they have been arranged from the north pole to south pole. Can you see that? But actually it's not accurate because I didn't keep it properly. Actually it will be like this. I'll just show. It will be like this. Here there will become C, here will become C, but here there won't be nothing. Just a net will be like this. And down to same. So that's called as a magnetic field, but it's not coming in this. Okay, so we can conclude by this that the magnetic field is from the north pole to south pole. So Earth itself has its huge So the Earth's magnetic field. So Earth to has a large magnetic field. So Earth acts like a magnet, but there is actually no magnet inside the Earth. So Earth's magnetic field is from south to north. It simply means that the magnetic geographic north, the geographic north, the magnetic south is located, and the geographic south, the magnetic north is located. That's why when I suspend this magnet, so you may think here is north, then this also will be this is the geographic north. See, it will repel. It's not repelling as the magnetic south is located here in the geographic north, while the magnetic north is located in the geographic south. So this is about the Earth's magnetic field. So due to this Earth's magnetic field, we are able to use the magnetic compass, which always points in the north and south direction. So magnetic compass has been used by sailors, pilots in the olden days. Okay, so making a magnet. So how to make a magnet? So there are 4 different ways. So we know this is a magnet. So magnet is obtained from our Earth, as well as it's made by man-made, and it attracts more pieces of oil. We all learned about that. Now we're gonna learn about how to make a magnet. Actually, we are not gonna learn about what chemicals we should add to make a magnet. No, I'm just gonna turn this iron piece into a magnet. How? So there are 4 different ways. So they are magnetic induction, then single touch method, double touch method, as well as electrical method. So magnetic induction method. So when this iron piece is brought near a magnet, it gets attracted. It's true. I'll use a very strong magnet. So this is a bit strong. So it's true. It gets attracted. So now I'm just gonna try out whether this attracted this piece of iron, because I'm keeping it here because it won't work. Yeah, see? Is this a magnet? No, it's just an iron nail. So what do you understand by this? So here, this is an external magnet. I just fixed it on the head. This is known as head and this is known as tip of this iron nail. And that magnetic field has been transported to this pole, and hence it has attracted. So here, this is the north pole. Hence this will be the south pole, as unlike poles, they attract each other. This will be south pole and this tip will be the north pole. So that's what we can understand by this. Now just see. It just remains. See, it just fall down. Why? So only in the presence of an external magnet, it acts like a magnet. acts like a magnet. So what do you mean by that? This type of magnet is known as temporary magnet. It acts for like a magnet for a short time and suddenly it gets demagnetized. So other type of magnets known as permanent magnets. That it remains a magnet permanently. Okay. So that's the only thing we learn about this. So next is about polarity during the magnetic induction. So you may be getting confused when you hear the word polarity. It's nothing than specifically if you need to show the poles means North Pole, South Pole. Commonly means will tell us polarity. So the polarity during the magnetic induction method. The same thing I'm taking. I nail and then magnet here. So here, this is the North Pole. That's true. So it's getting attracted here. So if this is my North Pole, both are getting attracted. Okay. So if this has been North Pole, it may have repelled, right? So this will be surely South Pole. So that's one of the polarity of this this iron nail. Next is this side. So as this is South Pole, this will be conformably the North Pole, and hence it attracts small pieces of iron. Can you see something else? Yes, right. This iron piece itself gets attracted to the magnet. Can you see? Okay. So these type of magnets are known as magnetic induction, but they are not permanent and they cannot be used for a long periods of time. So next method is known as single touch method. Single touch method is nothing that. So this is an iron piece. So how to make this magnet by just stroking it? Very easy. So take this an A and B, and I have a bar magnet. I just remove this. You can be like this. So this is a bar magnet, and it has two, and I'll name it as N and S. So now I'm going to place this N just vertically above the A end. So now I'm going to stroke it by moving it. Okay. So by moving it gently over the iron piece, and I'm just moving to the point B. Again, slowly, gradually raise the magnet, come to the point A, and then just stroke this for 20 times. So when you stroke this for 20 times, it becomes to be magnetized at the top. Then turn it upside down. Again stroke it for 20 minutes. So now it becomes a magnet, the temporary magnet. It's also temporary, and after some time it loses its magnetism. Okay. So the pole that touched the last which side you touch, that's the South Pole. So how we can decide that it's the South Pole? If this is South Pole and the last end which you have touched, then will be North Pole, and the other end will be the South Pole. So if this is the north side stroking pole, and if this stroke the last end, then that will be South Pole and the other end will be the North Pole. So this is the polarity during the single touch method. Double touch method. It's easy, but I actually don't have a cork. I just forgot to bring it. So it's not very easy. Just take an iron piece AB. Take two magnets. Two magnets. Place it in the middle, just vertical, and just place a cork between these two magnets. Think so you can see it. Between these two magnets. And just move them along the point. So this is A, this is B. Just move them like this. Just think that there's a cork here. So move them like this. Only difference is single touch method. We will just take the magnet. Here we won't be taking. It'll come like this. So without taking, we should do like this for at least 20 times. Then turn it upside down. Do it 20 times. So now it will turn into a magnet. Same polarity in the single touch method. The touched last becomes the opposite pole of the striking pole, and the N opposite to the opposite that pole becomes the. So this does not mean this becomes the south. That's all. It's simple. So the same polarity of single touch method. So now we are going to learn about the electrical method. So electrical method is also a temporary magnet. So all these methods are temporary magnets. So permanent magnets means you need to dig the earth and just take this limestone, or you should make a magnet by using the ferric oxide, everything. You should mix it and make a magnet. So these are temporary magnets. So this is an electrical method, but actually I just simply kept it. Okay. So now we can learn about the electrical method. So yes, the magnets which work in electricity are known as electromagnets. So these magnets are made by, I'll just tell how I made this. So this is nothing than a bar magnet, and I have wound copper wires, copper coils of wires around it, and there are some free ends. So these are the free ends, and we should attach it to the terminals. Terminals are the two ends of the battery. So there are two terminals, positive as well as negative. So now I'm going to attach this. So that's all. It's very simple. So this is an electromagnet. So these are the free ends of the copper wire, and I have attached to the two terminals of this magnet. So when I just bring it to the near an iron piece, see. But actually, one thing I did, that is, this is actually a magnet. But actually, electromagnets can also be made with a magnet as well as an iron piece. But mostly it won't work with an iron piece. Okay. So these type of electromagnets are also made with U-shaped magnet as well as the bar magnet. So the main property of an electromagnet is the pole becomes the south pole when the current is passing through the coil in clockwise direction, and the pole is the north pole when the current is passing through the coil in the anti-clockwise direction. Can you understand? I'll just show here. So here, if it is the current flowing in this direction, then this is the south pole, and if the current is flowing in this direction, this is the north pole. That's all. Simple. So this is so this is the making a magnet with electrical method. So now we learn about making a magnet. Now temporary and permanent magnets. Just wait a minute. So now we shall learn about temporary as well as permanent. So what do we make temporary? For a short time, and then it loses. Permanent. Permanently it has the property. That's known as difference between temporary and permanent. So now we can learn about temporary magnets. A magnet which loses its magnetic properties is known as a temporary magnet. For example, the magnets which are made by magnetic induction, single touch method, then double touch method, electrical method, so they are temporary magnets. For some time they excuse me, so they remain as a magnet, and when the current is taken off, that's switched off, they do not remain as a magnet. So that's the main thing. And the magnetic induction, only in the presence of an external magnet, this remains as a magnet. But when I take this out, see, it just falls down. So that's the main thing, the difference between the temporary magnet. Permanent magnets means, so these are permanent magnets. See, it doesn't lose any property. But if I give another magnet here, its magnetic power will get increased. So in permanent magnets, they do not lose their magnetic properties. Example, bar magnet. Then so they are mainly made up of steel, and temporary magnets are mainly made up of soft iron. So now we can learn about the differences between temporary and permanent magnets. A temporary magnet is made up of soft iron. A permanent magnet is made up of steel. Just consider this is temporary, this is permanent. So a temporary magnet shows its magnetic properties only in the presence of an external current. Due to the current passing through the coil, and permanent magnet shows its magnetic properties even after the current is switched off in traveling through the coil. The magnetic strength in the temporary magnet can be changed, and the polarity can also be changed by reversing the flow of current in that coil. The magnetic strength cannot be changed, and the polarity also cannot be changed. This is obvious. It's not that like only. It cannot be changed by south and north. So here, so the next is the permanent magnet. Examples: our bar magnet, then a U-shaped magnet, etc. And for temporary magnet, an iron nail, screw, then iron objects, etc. And even these iron fillings, they seem like natural magnet, but they are not. Then they may have attract this, but they are not attracting. But if I keep a magnet over them, they may have attracted this iron piece. So these are the main differences between temporary and permanent magnets. So electromagnets. So we already learned about a short description about them in here, by making a magnet with electric method. Electromagnets are nothing than the magnets which show their magnetic properties only the presence of the current that is passing through the coil wound around them. So how to make an electromagnet? So first of all, we should learn about its parts. It has three main parts: terminals, battery, core, and also the copper wire. Four. So now we can learn about how to increase them. So if I put an iron nail, it will be very little. Only one stapler pin it can hold. Really, I tried it. Only one stapler pin. But if I keep this magnet, already it's just imagine this. Its magnetic power is 9%. If I keep a battery, it becomes 12%. That's the difference. Okay. So choosing the core. This is the core. So the temporary electromagnets core should be made up of soft iron. Permanent electromagnets, so they should have a core which is made up of steel. They're permanent. Okay. So how to increase the strength of an electromagnet is just increase the number of battery cells which are involved to make this electromagnet, or increase the number of turns of wire, that's the copper wire, over this magnet. So when you increase these two, its efficiency becomes more. How to make an electromagnet? Very simple. Just take any type of magnet. You can do with any type of magnet. Here I have taken bar magnet. Just attach the free ends of it to the two terminals of a battery, and just leave it there. If you want this, you can attach a switch. So when you switch it on, see, it becomes an electromagnet. So it becomes a magnet temporarily for a short time. And when I just switch it off, but this will still work as a magnet, because this itself is a magnet. Okay, but we can also try it with iron nail. Okay, I'll just try it and show you now. So this is the main thing of the electromagnets. So electromagnets' main principle is the current that flowing through the coil in clockwise direction has the pole of south, and in anti-clockwise direction has the pole of north. That's the main principle of the electromagnet. Now uses. So now we can learn about the uses of the magnet. So there are many uses. We use magnets for different purposes. So one of the uses is, permanent magnets, they are used in electrical appliances like mobile phones, then computers, loudspeakers, dynamo. So these types of uses. And permanent electromagnets are used to separate the scraps of iron, to load scraps of iron, as well as to unload the scraps of iron. And also magnets are used. Have you seen this? There will be a crane. It will be having this big magnet. It will pass through a small jug means fully garbage, and it will have our steel and iron particle attached to it. Then they will take it to the processing, and they will recycle it. So this is also an example of magnet. So magnets are also used in doors, as well as in magnetic toys like chessboards. There are many, like even magnetic boards are there. Okay. So these are some of the uses. Main use of the travelers, like pilots as well as sailors, is magnetic compass. So you may think, how does it work? So you may think that there's a magnet here. No, there's no magnet. Only thing is, this is a magnet. So when I keep it like this, it always points into the north and south direction, as it has been attracted by the Earth's magnetic field. So that's why we use a magnetic compass to find geographic directions. Now, care and storage of magnets. Okay. Now, how to take care of magnets? So magnet has a tendency to lose its magnetic strength at any time. Hence, it's good to take good care of them and not to leave them by its own. So one of the way how to store is, so I want to store these two bar magnets means, so what can I do is keep them like this with their opposite poles. Should keep like this in their opposite poles. So at one direction, one side, so you can see in this part I should keep in soft iron. I didn't bring it. I can keep this soft iron and a piece of wood in the center. That's all. That's how we should store a pair of bar magnets. So during magnetic induction, opposite poles are formed in the sides of the magnet, and hence it does not lose its magnetism. In fact, usual magnet needs only one of the soft iron piece. Do you know how usual magnet used to be? It is like this. So here north south. So it needs only one soft iron piece to be stored. So this is one of the way of the careful storage of magnets. So now we can learn about the demagnetization. So if you have a magnet, it can lose its magnetic properties at any time. You may think, temporary magnets only. No, I mean permanent magnets too. Even I have a magnet. I used to drop it many times on the floor, and now it does not attract anything. If I stick it in the bureau, it does not get attracted. It always falls down. But I do not have it now. So that's an example of demagnetization. So magnet loses its magnetic properties at any time. So some of them are heating them at high temperature, dropping them from the heats, then always just suspending them from a thread and making them to point in the east-west direction. And also using the magnets in loudspeakers and using them for a long time, like damaging them, then playing with them. Actually, magnets are not for playing; they are only for use for purposes. So even some people do like this. If any speaker is not working, some children they take the speaker, break it, they just break it, see whether any magnets inside. I learned now there's a magnet. They'll think and they'll find a huge magnet, and they just play with it. No, you should not do like that. So magnets are used for many purposes, and if you do like that, it will lose its magnetic properties and get demagnetized. And do not use the magnets in high temperature. So when you're out, when it's very sunny day, don't use the magnets. So a small fact can I give you. So if you need to find the to make an iron piece in a magnet, you can also perform this. Take an iron piece, just keep them under the sand, keeping them in north-south direction, then leave. After 1 year or 2 years, come and just take out the iron piece and become a magnet. So this is because I kept it in the north-south direction. If I keep it in the east-west direction, nothing will be gone. Nothing will happen. That is, it won't become a magnet. So always a magnet will face in the north and south direction. Okay, so now we can learn about this summarize. So we learned about discovery, natural magnets, artificial magnets, the magnetic and non-magnetic substances, characteristics, properties, magnetic field around the magnets, Earth's magnetic fields, making a magnet temporary and permanent magnet, the differences, electromagnet, the uses, gas storage and demagnetization. So I told you that we can also do with the help of this iron nail. It's very easy. I'll just tell you, but I can't show. Just wrap the coil of wire, copper wire in it. Attach the free ends of it to a battery. That's simple. But its magnetic power won't be much strong. So that's the only difference between the attaching a magnetic substance to a battery and a magnet to a battery. That's the difference. Okay friends, so hope you enjoyed my class today. So see you in the next class, but I'll just show you how this exactly looks. You have not seen it properly. This is how it looks. Can you see? So we can get these iron fillings by just keeping a magnet over the soil. I got it from the soil. If you keep it over the soil, you may get this. So these are known as iron fillings. So they are also known as magnetite or lodestone. So see you in the next class. Bye bye.